Voice of the Sea, learning from experts across the ocean. Welcome to Voice of the Sea. In this episode, we're learning about how fish help corals grow with biologist Andy Brooks from the University of California, Santa Barbara. Andy and his colleagues, Rush Schmidt and Sally Holbrook, have been studying the reefs in Moorea in French Polynesia for over 15 years. Their research shows that fish and coral are much more connected than most people think. It is commonly known that coral provide fish with important habitat, but their research shows that fish are also beneficial to coral. Some species of fish protect coral from predators and overgrowth of algae. This new research shows that fish also provide coral with nutrients. In this episode, Andy shares his research and provides tips about how everyday practices can help protect coral reefs. So we're about to head out on the boat with Andy Brooks and take a look at some of the field sites that he's been working on with his team for the past few years. Hi, Andy.
Hi, Kenisa. All ready to go?
Yep. So where are we headed?
So we're headed to an area of the lagoon along Moorea's north shore, and we just call it Pavement Nui. It's an area of exposed reef that's a fairly new reef, hence the Nui, new pavement. And this is an area that we've been studying along with some of our colleagues from the University of Florida have been studying for quite a while. What I want to show you today are some of the last remaining Poeciloptera that actually survived the crown of thorns outbreak a few years ago. And one of the reasons why they survived was because they were growing up on top of several other really tall dead coral or other species of coral. They got them up off the bottom.
Oh.
It sort of provided them with a little bit of a refuge from the crown of thorns. And so that's sort of the setup for why we still go to this site, is that there still are these large Poecilopterid corals. What I really want to show you are the fish that are associated with the corals, because we found that these fish that take refuge in the branches of the corals at night, they actually release ammonia just as their normal waste product. I mean, anybody that has a home aquarium knows, one of the things you have to watch out for is too much ammonia building up in your tank, and that's what fish release as their waste product. And it turns out that the Symbiodidium, the little photosynthetic dinoflagellates that live in the coral tissue, well, they're plants like any other plants, and nitrogen to them is fertilizer. And so by releasing this nitrogen in the form of ammonia into the spaces within the coral, they actually promote coral growth.
So the fish are actually helping the coral grow?
The fish are helping the coral grow. And so it sets up this sort of positive feedback loop where the fish are causing the coral to grow faster, which then makes a larger coral, which provides more space for more fish, which produce more ammonia, which make the coral grow even faster. So a lot of people know that coral provide a really important service to fish in giving them shelter. What's not as well known is all the benefits that the fish actually offer the coral in return. So it really is a true mutualism. Each species is getting some benefit out of being in association with the other species. The fish get shelter from predators, and the coral get this increased nutrient in the form of the ammonium. In some cases, there are fishes that actually help protect the coral from fishes that may feed on coral or from crown of thorns sea stars.
How do they protect the corals?
They actually come out and they nip the sea stars. They nip the tube feet of the sea stars and cause them to sort of go somewhere else.
They're just trying to protect their home.
They're trying to protect their home, yeah. It's a really nice little example of mutualism. And of course, the coral reef is the greatest example of a mutualism there is. It's the mutualism between those little photosynthetic dinoflagellates, the Symbiodidium, and the coral animal itself. The coral is an animal, but within its tissues are these plants. And so the coral is providing shelter, and the Symbiodidium are providing nutrients in the form of food. Like all other plants, they photosynthesize, so they're able to make complex sugars just from carbon dioxide and water and sunlight. So that real tight coupling, that mutualistic relationship is what makes coral reefs possible. in many cases. And so we're finding almost everywhere we look on a coral reef, there are examples of ecological mutualisms. It was, for many years when I started off as an ecology grad student, the only relationships between species that people discussed were competition and predation, right? Those were the big ones. Now we're finding other examples of interspecific relationships are just as important, and mutualisms is one that's really coming to the fore as a relationship that's incredibly important in a lot of different ecosystems, not just coral reefs. But it just seems like everywhere we look out here every day is some new mutualism going on. It's pretty exciting to see how interconnected all the organisms on the reef really are.
And these are systems that have evolved over time to work together.
Thousands and thousands of years. Back in the early days of sort of science philosophy, the earlier philosophers who thought about science likened the world to a well-constructed clock. Each organism had its own place in making the clock run, and it was a system that was in perfect harmony. And we've moved away from that concept of the environment, but what we are finding is over time, a lot of these animals have evolved in relationships with one another that actually serve each species to the benefit of the other. And so we're getting these marvelous mutualistic relationships that have built up over thousands and thousands of years that make things like coral reefs possible.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
Welcome back. We're heading out to the research site with Andy Brooks in Cook's Bay on the island of Moorea.
So we're aiming for that little exposed piece of coral, that little exposed reef right through.
Oh wow, do you have any idea how come it was lifted up?
It's just an area that's been uplifted, just a little bit faster growth of the reef.
Oh, I see. And is it out of the water at all tides?
Yeah. The tidal range here in Moorea is very low. It's only about 30 or 40 centimeters between the extreme highs and the extreme lows. So, we're talking not very much. And the only tricky part is you have to sort of pick your way through this coral field to get out there. So if you could just slide forward on the bow and be my spotter and just let me know if you see any tall corals that we might
Okay, you got one on the side
into.
here.
Just sort of point me on a path.
It's getting really shallow right in
Okay.
front of us. Like maybe the backup kind.
Okay. Just go ahead and throw all that chain out, and that's probably fine. We don't have much wind today.
So we're gonna get in and take a look at your site.
Yeah, so what we're looking for is on a lot of these corals, you'll see some yellow tags with numbers on them.
Okay.
And each one of those tags corresponds to a coral that we've been following over about 3 years. And a lot of those are either Poeciloptera or Acropora, which are the perfect corals that fish like to shelter in at night. So those are the ones we're trying to find. And they won't be right on the bottom near the sand, they'll be really up near the tops of the coral heads.
Okay.
So that's what we're looking for.
And then what are the fish that are associated with those?
So most of them will be little damselfish. The green ones are blue-green damsels, Chromis viridis. You may also see some black and white striped ones, humbugs, Dacilus arowanus. And then there'll be some longer ones. There's one that's sort of a brown color with an arc over its eye. That's an arc eye hawkfish.
Okay.
And there may be another species of hawkfish is bright red, the flame hawkfish. And they'll be deeper down in the branches.
Oh, okay.
Yeah, but all of those fish shelter in corals at night, and they're some of the primary species that are responsible for this sort of growth effect that we see.
They're all producing ammonia.
They're all producing ammonia, yeah. All fish produce ammonia as a waste product. Most non-sharky fish release it through their gills. And any fish that's in the coral or closely associated with the coral is going to help by releasing that ammonia. And then, of course, the other things you have to take into account are how tightly branched the coral is, because that influences how fast the water moves through the coral and washes that ammonia away. And then the current speed. So it's really about the rate at which the fish produce the ammonia and the rate at which the water moves it through, right? And so the more tightly branched or the slower the water movement, the longer the ammonia stays in the coral and the greater the effect that it has.
So the more branching corals will have a tighter mutualistic relationship with the fish. Then.
Yeah. And of course, the more tightly branched they are, sort of the more shelter, the better quality shelter they provide for a lot of these little damselfish. I mean, most of these damselfish are only about this big, so they can really wedge themselves down into those tight spaces. And then a lot of the predators, big bluefin trevallies, jacks, groupers, are just much too large to get in there and get them out.
Let's take a look.
This is work that really I'm doing in collaboration with some colleagues at the University of Florida, the University of Georgia, and the University of Victoria in Wellington, New Zealand. And what they're interested in is the effects of these worms, repeated worms, that actually cast out a mucus net to catch food. But in the process, they cover the coral. And so some people have suggested that may actually damage the coral and cause the coral to grow in sort of unusual ways. So they've got coral heads here where they've removed all of those worms, and then other ones where they've left them in place. And they're looking to see the effects on all of the little individual coral heads that are growing on those corals. So every year we come back, we do a census, we look to see which ones are alive or dead. If there are any new ones, we mark those. We actually survey all the fishes that are associated with the corals, and then we do surveys of how many of the little vermidid worms are actually living on the coral head itself.
Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org. Welcome back. We've just finished our snorkel, investigating the coral cover at Andy's study site. The research that Andy, Russ, and Sally are conducting demonstrates the relationship between organisms on the coral reef. The small fishes, like damselfish and hawkfish, pee in the water. This acts like a vitamin, providing nutrients directly to the corals in small amounts. Ironically, large amounts of nutrients, like those from agriculture and sewage runoff into the water, can be very harmful to the reef. The nutrients and sediment themselves can also cloud the water, blocking corals' access to sunlight. I was surprised to see how much of the coral is dead, and is that what you would typically expect in a healthy lagoon area?
It's hard to say whether it's healthy or not. It could be just part of the natural cycle that the reef goes through. when I first started working here about 15 years ago, there was a lot more live coral in the lagoon. A lot of those big, massive Porites, rust bommies were, alive and in really good shape. There were a lot of damselfish that were all over them. And we've been seeing sort of a general decline in the coral within the lagoon over the last probably 8 to 10 years. Now, whether or not that is a response to too much nutrients coming down from the valleys with agricultural activities, or sedimentation coming in because of coastal development, or if it's just a natural process of the lagoon sort of cycling and corals settling out, recruiting, growing, and then senescing and dying, and then another generation coming in to replace them. We haven't been sort of here long enough to see that. But that's one of the really important things about these long-term ecological research sites, is they're set up to look at questions just like that. Things that take 20 or 30 years before you can actually say, well, is this a one-time die-off and the reef's really dying? Or is it just a cycle and the reef will recover in another 4 or 5 years?
So then at the end, or over time, if you figure out that there really was a problem, is it too late to do anything?
Yeah, it might be. It might be. And so if all we were doing was sort of monitoring the status of the reef, then we would run into that situation of, well, we tracked it and we tracked it right off the cliff.
Right.
And what do we do? So a lot of what we do is not only following how things are changing through time, but attempt to predict what's going to happen. And we do that by doing all of these sort of short-term experiments that are really designed to tell us exactly what it is that's causing the changes in the reef. So instead of just observing the changes, what are the mechanisms that are responsible? What are the things that are behind the changes? And if we know that, then we can try to make some predictions. If things stay the way they are now, we expect the reef to continue to degrade. Or if we can change the amount of nutrients that are flowing into the lagoon, we would expect the reef to recover, or at least the cover of live coral to increase, for instance. And so a lot of what we do is really geared toward that ability to make predictions into the future.
What can the average person at home who cares about the health of coral reefs do?
So there are a lot of things that we can do. One of them is, if you're a home aquarist, you really like having fish or a coral reef tank or something in your home as a hobby, that's great, but make sure the source of the material for your tank has been responsibly collected. And so we really don't encourage anyone to use live coral that's been collected from the wild. There are lots of businesses now that are culturing and growing live coral that you can use as a source. And then there are a lot of even tropical fishes that are captively bred. Or they're caught in sustainable ways, and they don't represent species that are threatened or endangered. And so we would just encourage home hobbyists to be aware of where your fish, where your coral, where your snails, your anemones are coming from and how they're being caught. Another thing is there have been quite a few studies recently looking at the effects of sunscreen on coral. And so it's great to go on vacations to places like Hawaii or Moorea or Thailand. But if you go and you're snorkeling, don't touch the coral. We were very careful today not to touch the living coral. We touched little bits of areas that were dead and were sort of just dead reef matrix. But you don't want to touch living coral. You don't want to touch living anemones. You certainly don't want to bring snails home with the pretty shells or something like that. And just be aware of sunscreen. Obviously, you want to wear sunscreen, protect yourself from any damage you might get from the sun, but be aware that when you have that on you, you don't want to be out sort of getting close to live coral and exposing them to all the chemical compounds that are in that sunscreen. Another thing we encourage people to do if you're a boater is to just make sure you're anchoring responsibly. Don't use the reef to basically be a mooring for your boat. We anchored in a nice sandy patch there and made sure our anchor was set. If it's so rough that you have to wrap your anchor around live coral, maybe it's not the best day to be boating. But we've seen a lot of boat damage on the corals in the lagoon from people that have come in and essentially they want to make sure in a high wind their boat doesn't drift and they don't drag the anchor, so they wrap the chain around a massive Porites bombing. Of course, then the anchor chain just rubs up and down all night long as the boat swings around, and it just scrapes all the living coral off. People being aware of the hotels that they stay in. Do those hotels treat their sewage, or do they just pump it, out onto the reef or out into a lagoon? And so being a little more eco-aware when you book your hotel on a vacation can make a difference as well. We encourage people to go onto sites like Yelp or TripAdvisor or something if you're with a particular tour group or hotel that you feel is really doing a good job of protecting the reef and being good stewards, that you go on and you let other people know so that they will go there, and eventually this sort of the business will help correct some of the people that maybe aren't doing such a good job. So we just see so many examples of people out here just trashing things, and whether or not they just don't know what they're doing, they just don't realize the effect that they're having. It's probably most of the cases. But I'm sure there are a few cases where people just don't care. And what they don't realize is you can only push this system so far and expect it to be able to recover. And eventually, you push it over a cliff, it's off the cliff, it's done.
The coral reef environment is an amazing balancing act, with each organism playing an important role. Our human actions on land and in the water have direct effects on the reef ecosystem and the relationship between these organisms.
The Curriculum Research and Development Group in the College of Education at the University of Hawaii at Manoa. CRDG's training roots go back over 40 years. Through professional development programs, curriculum workshops, research on teaching methodology, individualized school and district training, and so much more. The Curriculum Research and Development Group, improving schools, improving education. CRDG.
Turn your love of the ocean into a lifelong career. Join NOAA, the National Oceanic and Atmospheric Administration, as we unlock the secrets in the deep oceans, track rapidly moving storms, model climate trends, protect and preserve our marine resources, and so much more. It's all in a day's work at NOAA. Find a career that makes a world of difference, enriching life through science, service, and stewardship. NOAA.
Healthy oceans are critical to our cultural, economic, and environmental sustainability in Hawaii. The ocean serves as a source of water, food, medicine, jobs, transportation, recreation, and energy. It controls climate and weather. Kosi Island Earth aims to share this ocean awareness by partnering with local scientists and educators to engage communities and schools in active science learning for an ocean-literate population. Kosi Island Earth is working to establish new avenues for connecting research scientists with educators and communities. Kosi Island Earth is enhancing the science and ocean literacy of our island residents and visitors. Kosi Island Earth is connecting scientific research, traditional knowledge, and ocean policy. Kosi Island Earth, bringing together university, government, research, and community partners to improve science education and ocean stewardship in Hawaii.